The next important concept in EAS is directive influence. That is, suppose already a group is present on the benzene ring. For example, if you take this benzene ring, there is NH2 group. We have earlier discussed that NH2 group is an activating group. That is, it pumps electrons into the benzene ring. But NH2 is activating especially by mesomeric effect, or you can call it resonance effect, plus N effect. Now, directive influence is mainly decided by mesomeric effect. Everybody should keep that in mind. Directive influence is decided by mesomeric effect. So just by mesomeric effect, what is happening? This NH2 is donating electrons into the benzene ring. That is, these electrons are shifted here. That's why there is a double bond. So nitrogen gets a positive charge. So as a consequence, this bond is shifting here. So there is a negative charge on this carbon atom. So if you observe, negative charge is present here. This further continues. I am writing this once again, but now I am showing the arrows. This negative charge shifts here. That is, the arrow is pointed like this. As a consequence, this bond shifts here. That's why the arrow is pointed here. So this bond shifts here. So a new bond is formed because of this, and this becomes a negative charge. This as it is. Further, this repeats. This negative charge shifts here, and this double bond shifts here. So new negative charge produced here. This has become the double bond now. This returns back to the original structure. This shifts here. As a consequence, this nullifies the positive charge. You get back the original structure. If you see, earlier the double bonds are like this, and like this. After the complete resonance, they just shifted the position like this. So that is the complete resonance pattern to show. Now, if you look overall, negative charge was either here, here or here, but never at these two positions. So now first let us know the naming of the position. Suppose there is an activating group or any group. Since this is an activating group, I wrote here. For any group, this is a group G. The next positions are called ortho positions. The second next positions are called meta positions. The opposite position is called as para positions. So both of them are same, only one is there, it is para. So if you observe, negative charge is produced at ortho, negative charge is produced at para, and again negative charge is produced at ortho. This is also ortho. So a plus sum group or a ring activating group by mesomeric effect will always produce negative charge at ortho and para only. So now on to this NH2, if I take this NH2 and if I add an electrophile is looking for negative charge. The negative charge is at only this position or this position. So the electrophile might attach and form a product like this. That is ortho product. This is the ortho product. Or the electrophile might attach and form a product like this. That is the para product. But never electrophile will attach at meta position as long as it is NH2 group. That is, as long as it is an activating group. Why? Because negative charges are only either at ortho or at para, but not at meta. So electrophile will form either ortho or para only, but not meta product. So that is why the direct influence of activating groups which are by mesomeric effect is ortho-para directing. That is, they direct the incoming electrophile towards ortho or para position. Now let us take a deactivating group. This is a deactivating group as well as minus M group. So if you look at a minus M group, the double bond goes out of the benzene ring. That is, electrons are pulled out of the benzene ring. As a result, what charge is produced? Positive charge here. Repeat this resonance we have seen earlier. So positive charge is produced here. Repeat the resonance. This double bond shifts here. Positive charge is produced here. Finally, it goes back to the original structure when this bond shifts back. So now if you observe, at ortho and para there is positive charge. At meta there is neutral charge. There is no charge. It is neutral. So now imagine the scenario if an electrophile has to attack. Generally it won't prefer to attack this because electron density is less. If there is benzene and NO2, it will prefer to attack benzene but not NO2. If there is nitrobenzene and benzene, it will prefer to attack benzene but not nitrobenzene. But if there is no other option and it has to attack nitrobenzene, what do you think? Will it attack at this position and this position, or will it prefer the meta position? Obviously it will not choose the ortho and para because already positive charge is there. Electrophile is also positively charged. So now if an electrophile attaches, it is going to attach at meta position. Because here there is a positive charge, here there is a positive charge, here there is a positive charge in the resonating structures. So it will prefer to attack at meta. So this means this group is meta directing group. So if I can say if a minus M group is attached, it will be meta directing, that is the incoming electrophile will prefer to attack at meta. If a plus M group is present, the incoming group will prefer to attack at orthopara. Now just I'll sum all of them up. Suppose NH2 is present and just benzene is present and just NO2 with benzene is present. Electrophile, if it wants to attack, first it will attack this one because this is activating. When it is attacking these two, it will either attack at ortho or it will attack at para. Either this or this. Which of these two is major to be decided later. If this is not there, then among these two it will choose to attack this one. Any position is the same for this. Now when these two are not there, only this is left, it has no good intention to attack on the NO2 group. But it is reluctant to attack on this nitrobenzene. But since there is no other option, only nitrobenzene is present, it will not attack here, it will not attack here, it will not attack here. So what position is left? Only meta. So it will attack at meta. That is how it is meta directing group. Got it? So overall, if I say direct influence is majorly decided by mesomeric effect. If inductive effect is also operating, then it will help the direct influence. Suppose it is a plus M group and a plus I group also, then inductive effect is based on proximity. Then it will prefer to attack ortho over para group. We will see such examples in the next part. This is direct influence.